Hello, everyone. Today we're gonna do a lecture on proof mechanisms. So how we use different approaches to prove something is correct. So actually, the methods we're gonna use it to prove something are listed here using direct proof, using proof by exhaustion, using proof by contradiction, by contraposition, by demonstration, by counterexample. And in semester B, we're gonna do a very intelligent proof methodology called proof by mathematical induction. So all of those will be covered today, except the last one will be covered in semester B, okay? So what's a direct proof? Is a direct proof is that you start with premise or tautology, and you write down sequence of statements which will also be true using something you already know, using using algebra, using theorems, using logical equivalence, using inference rules, things you already know from previous lectures until you arrive to a conclusion يا شباب, okay? So هنبدأ بإيه؟ هنبدأ بإنبوت apply steps directly, substitution, something like equivalence rules لحد ما نوصل للconclusion بتاعنا. تعالى let's have an example. So here is the thing we want to prove. We want to prove that if n is odd, then n squared plus n is even. So this is the given, and this is the conclusion you want to drive at the end. And let's start with n. If n is odd, so if for even numbers, it could be written as twice k, where k is some integer, okay? But for odd numbers, it could be written as twice k plus 1, okay? Where also k is an integer value. So let's get benefit of knowing that n is odd number. And we assume that because n is odd number, so it will take this form, twice a number plus 1, where this number is an integer, twice n plus 1. And substitute here in the equation you want to drive, or you want to prove that its outcome is even. So would like to have n squared. N squared is equal to twice n plus 1 squared, which is square the first part, square the second part, and multiply the first times the second times 2. So it's 4m squared plus 1 plus 4m. So this is what's equivalent to n squared, this part, plus n, which is the same form you assumed. And now you would like to prove that all of this is even. So you would like to prove that the outcome could be written as twice k, twice integer, twice times an integer value. So now, يا شباب, here we have 4m squared, 4m plus 1 plus 1. So plus 1 plus 1 is plus 2. 4m plus 2m is 6m. 4m squares added to 6m plus 2. So you can have a common factor, which has a value of 2. And the remaining here is 2m squared. And from here is 3m. And from here is 1. And you can just say, okay, you know that m is an integer. So m squared is still an integer. Twice m squared is still an integer. Plus 3m is an integer also. So if you add two integers together, you will get an integer. Plus 1 is an integer. If you add 1 to an integer, so the overall is integer. So you can just say this is twice k or twice x, where x is some integer, which means that n squared plus n has the form of even number, so it's even. So now we use the direct proof mechanism to prove what we want to prove, okay? Another example, using inference rules. Assume that if this is true and this is true, so conclude not A. Okay, why not? So this is the premise, this is the premise. And now let's use the rules we know in order to conclude what we want to prove. Okay. So using a conditional statement here, this could be equivalent to not A or B. And here it's not A or not B. So if it's not A or B and not A or not B, which means that those two happened at the same time, I can have a conjunction between them, and now I can have not A as common factor, and the remaining is P and not B. P and not B is always false, and false ORed with anything, this will be the value of the result. So not A ORed with false, it gives a not A. So this is what you want to prove يا شباب, okay? So actually الانفيرنس rules اللي أخدناها قبل كده, it's a way of proving things using direct proof mechanism. Okay? So your turn. Assume that n is twice k plus 1, which means that n is an odd number. Assume taking the square root, it gives, we want to prove that if n is an odd number, so n squared is also odd. So what you're gonna do is that you will get the result of n squared, that's it, and you will try to put it in a form of odd numbers. So this is odd number, could be twice x plus 1. So the 1 is here. You want this part to be written as twice an integer. It's very easy. You can have 2 as a common factor from those two terms, and the remaining will be here twice k squared plus twice k. And you know that if k is an integer, all of this bracket is an integer, so it could be written as twice m plus 1, where m is some integer, so this is the form of odd number. So this is what you want to prove, that n squared is odd. Okay, Shabab? Okay. So let's do the second way. The second way to prove things is to do proof by exhaustion, or it could be called in some other textbooks as proof by cases. So a technique to prove or disprove a proposition by evaluating all the cases, all the possibilities. We had dealt with something similar to this way, which is to prove something or to calculate something on a truth table for propositional logic. We want to prove that if A implies B and A implies not B, then you can conclude that it is not A. So what you want to prove that if A implies B and A implies not B, this implies not A. So you want to prove that actually this is a tautology. If you prove that this is a tautology, so this is a valid conclusion. Okay, so what you're gonna do now is to try to list all the possible cases for the inputs, which are A and B. So because here we have two inputs, A and B, so the number of combinations are 4, true and true, true and false, false and true, false and false. So first, you're gonna have to calculate A implies B. So A implies B, true implies true, it is true. True implies false, it's false. False implies true, it's true. False implies false, it's true. And you can calculate the negation of B. B is true, false, true, false. So the negation of B is false, true, false, true. And now you can calculate A implies not B. A implies not B, so this is the left side, and this is the right side. True implies false, this is false. True implies true, this is true. False implies false, this is true. False implies true, this is true. So here is the results for A implies not B. And now you would like to have the and, the conjunction between the two together. So the conjunction between this column and this column, true and false, this is false, false and true, this is false, true and true, this is true, true and true, this is true. So here are the results, false, false, true, true. And now you would like to calculate if A implies B and A implies not B, then it's not A. So you will try to calculate not A. So here, not A will be, instead of having A true, true, false, false, so the negation of A will be false, false, true, true. And now you can use this as a left side for the implication and use this for the right side of the implication and try to find all the compound proposition which is written here. False implies false, this is true. False implies false, this is true. True implies true, this is true. True implies true, this is true. If this is a tautology, so this is the valid conclusion. So يا شباب دلوقتي we considered all the possible cases for the values of A and B, and we proved that this statement is true at the end. When A is true and B is true, it is true. When A is true and B is false, it is true. When A is false and B is true, it is true. When A is false and B is false, it is true. So for all cases, it is true, which means that this is a valid conclusion. Okay? So, for proof by exhaustion, this is an easy way to prove things, but be careful because, as you know here, we had two variables. So the number of rows in the truth table were 4 rows. If we have 3 variables, so you're gonna have 8 rows. If you have 4 variables, you're gonna have 16 rows. If you have 10 variables, you're gonna have to do 1024 rows, which is more time consuming. So proof by exhaustion, it's easy, but it takes lots and lots of time if the number of them is great. Okay, sorry, is high. So let's consider another way for proving. Another proving mechanism is proof by contradiction. So, okay, I would like to tell you, okay, can you prove if something, then the other thing? If the condition happens, so the conclusion happens. So, okay, the proof by contradiction based on a trick, which is assume that the opposite of what you want to prove is correct. So هنعمل ايه يا شباب؟ هنفترض ان اللي انا عكس اللي انا عاوز اثبته صح، واحاول امشي في الاثبات وابين ان الفرضيه بتاعتي اللي انا فرضتها دي عمرها ما تحصل، غلط. وبالتالي ما دام عكس اللي انا عايز افرضه عمره ما يحصل، يبقى اللي انا عايز افرضه هو اللي صح. Okay, so this statement that we have proven twice كانت دي. The idea of proof by contradiction is that effectively we have, if A implies B and not B, which means A implies false, from which we can conclude اللي بيحصل علشان دي كلها تبقى بترو لازم الليفت سايد يبقى هو اللي negated, which means not A should happen. Okay, طيب تعالى نستفيد بالايديا دي. Suppose we want to prove that A is true. If we can show that A being false leads to contradiction, so A must be true. ده الموضوع ما فيه. عايز تثبت ان ال A بترو، افترض ان هي بفولس واستخدمها في الطريقة اللي هتمشي بيها، وحاول تثبت ان الفرضية دي هتدي لك حاجات متضادة لبعضها، يبقى الفرضية دي عمرها ما تبقى صح، يبقى عكسها هي اللي صح. عكسها اللي هي ايه؟ اللي هي اصلا اللي انت عايز تثبتها. اوكي. So let's practice. Prove that the sum of two even numbers is always even. Okay. So we start دلوقتي. ده اللي انا عايز افرضه. تعرف تنفي لي اللي انت عايز تفرضه وده يبقى هو الانبوت بتاعك؟ يس. نفي الستيتمنت دي ان summation of the two even numbers is not even, which means not always even. يعني هي ايه؟ يعني هي odd. حلو. So there must exist two even numbers. When you add them together it gives an odd number. ده بقى الفرضية اللي انت هتثبتها، سوري، الفرضية اللي انت هتفترض انها صحيحة. We use this assumption in your proof in order to say that it cannot be the case. There is something contradicts what I already assumed, which means ان الاسامبشن كان غلط، يعني عكسه هو اللي صح، اللي هو اللي انا عاوز اثبته اصلا. So let's practice more. Proof by contraposition. Proof by contraposition. Here is an example. Show that 5 times n plus 4. If this is odd, then n is odd. حلو الكلام؟ Yes. So الstatement اهي، ده ال P implies Q. We want to prove that P implies Q. So يا شباب هشوف السلايد بس اللي قبلها. التكنيك بتاع البروف باي كونتراديكشن بيعتمد على رول من اللوجيكال ايكويفالنس رول، اللي هو ايه؟ اللي هو P implies Q هو بالظبط ان not Q implies not P. ده البروف باي contraposition. ماشي يا شباب؟ by contraposition. Sorry, I jumped to another way of proving things. This is proof by contraposition. Before I do this, let's practice proof by contradiction. تعالى المثال ده. I thought انها محلول بعدها. احنا قلنا the summation of two even number is always even. So هقول ايه؟ هقول assume that ان النمبر الاولاني is x والنمبر الثاني y ودول are even numbers زي ما هو قال لي. انا I'm gonna assume that x plus y is equal to z where ان z is odd اللي هو عكس اللي انا عايز اثبته. وتعالى because you know that x is even so x is twice k. Because you know that y is even so y is twice m. For example, k and m, it could be different. It could be the same value, it could be different. So add them together. So x plus y is twice k plus twice m, which means twice k plus m. Adding integer plus an integer, it generates another integer, which is twice l. So now you know that x plus y has a form of even integer. However, you assumed that it's an odd value. So this contradicts the assumption, which means that this assumption is wrong. So its opposite اللي هو ايه؟ اللي هو actually what you want to prove is correct. ان عمر ما يبقى السمشن ل two even number هيجنريت odd number. امال هيجنريت ايه؟ هيجنريت even اكيد، عكس اللي انا الفرضيه الغلط اللي انا فرضتها. Okay, so now we dealt with proof by contradiction. The next way of proving things is proof by contraposition. وخدناها يا شباب في كان اسمه ايه؟ propositional logic. وجالكم في الامتحان الاولاني ان P implies Q الكونترابوزيتيف بتاعه اللي هو قراه من اليمين للشمال بس بالنيجيشن not Q implies not P. سو يا شباب عايزك تثبت ده ممكن تروح تثبت الايكويفالنت بتاعه صح، ولو الايكويفالنت بتاعه صح يبقى هو صح. طب عاوزك تثبت ده، تثبت ان الايكويفالنت بتاعه صح، ولو الايكويفالنت بتاعه صح يبقى هو صح، عشان الاثنين equivalent to each other. طيب اوكي. prove that if 5n plus 4 is odd, then n is odd. So this is if then. P implies Q. مين ال P؟ ده ال P. n 5n plus 4 is odd. ومين ال Q؟ ده ال Q. أنا متعود إيه؟ متعود إن الفرضية بتبقى بسيطة شوية عشان أستخدمها في حاجة معقدة وأثبت بيها اللي أنا عاوز أثبته. أنا عشان أمشي this way الفرضيه بتاعتي البريمس بتاعي حاجه معقده اصلا. لما اقول له 5n plus 4 is odd، يعني اقدر اكتبه على هيئه twice k plus 1. يعني اقدر اعمل ايه يعني؟ ما انا مش عارف. هروح اطرح اودي الفور دي اليمه الثانيه واقسم على 5 والاقي الدنيا اتلعبكت معايا ومش هتبقى ظريفه قوي. If you didn't feel like okay this way is an easy way and you feel like it's opposite it could be easy، هات الايكويفالنت لها. الايكويفالنت لها using contrapositive. الcontraposition ان not Q implies not P. not اليمين implies not الشمال. وتعالى نقراها بقى. وبالتالي انا ممكن اريفريز الستيتمنت دي to another statement زيها بالظبط. عايز اثبت ايه؟ if n في دي n is not odd يعني n is even. يعني اكني بقول n is even. then n في ال P هقول له then 5n plus 4 is not odd، معناها إنها برضو even. يعني عايز أثبت اللي أنا لو ال n is even 5n plus 4 is even also، وأني أثبتها it's easy. أنا n is even so it could be written as twice k where k is an integer. So now you need to substitute and calculate 5n plus 4. So 5 times twice k plus 4 is 10k plus 4. وأنا عاوز أثبتها على إنها even، يعني أحطها على هيئة twice k أو twice m twice a number، يعني twice an integer number. So you can have 2 as a common value هنا and the remaining would be 5k plus 2. So 5 an integer, it's an integer added على 2 it's an integer also. So this is twice L where L is some integer which means that إن ده كله is even. So يا شباب أنت أثبتت الكونترابوزيتيف بتاعتها إنها true، يبقى هي كمان true. Okay, this is the contraposition يا شباب. Okay, your turn. Prove that if n is an integer and 3 times n is odd then n is odd. انا ملاحظ ان انا هبدا بحاجه صعبه. لا، هات معكوسها المكافئ لها اللي هو الكونترابوزيتيف، يبقى n في الكونسيكونس. وبالتالي هقول if n is not odd يعني even then n في الكونديشن ان 3 times n plus 2 is not odd which means انها even and it's very easy to prove that. هقول ان ال n is twice k وسبستيتيوت هنا 3 times twice k plus 2 which is 6k plus 2. I'll take 2 as common factor so the remaining is 3k plus 1. 3k plus 1 is another integer which is m, so this is twice m is a form of even number. So I proved that its contrapositive is true, so this statement is also true. اوكي يا شباب، حلو قوي. Prove by demonstration. Demonstration, it's like, okay, it's a way of disproving things or proving things. بس الحاجات دي لازم تبقى ايه؟ تبقى finite. Usually we use it to prove the extensional quantifier. something like okay prove that there exists a value بتعمل لي الكلام ده. اوكي اعمل بروف ازاي، اثبتها ازاي؟ ان انا اجيب له value تعمل اللي هو عايز يعملها. يعني هنا دلوقتي prove that some prime numbers are even some. انا ما قلتش all، قلت there exists a prime number which is an even. So proof by demonstration is that okay show me an example where it satisfies what you want to prove. So here I can say 2 is a prime number and 2 is an even number, so 2 is even and prime at the same time, which proves what you want to prove. Okay يا شباب؟ So proof by demonstration ده سهل قوي، اديله مثال يحقق اللي هو عايزه، بس اللي هو عايزه لازم يبقى ايه؟ يبقى extension quantifier مش all. ما ينفعش اقول له prove that all prime numbers are even، لا يبقى كده انا لازم اعدي على كل الاعداد الممكنه البرايم which is infinite number. ما ينفعش اديله مثال واحد بس. طب disprove by counter example ده عكسها، ان انا عندي universal quantifier انا would like to disprove ان الuniversal quantifier ده موجود. universal يعني ايه؟ all اللي انا لسه قايلها من شويه. would like to prove that all prime numbers are odd. disprove it يا شباب. يعني ايه disprove it؟ يعني قول لي ان الستيتمنت دي مش صح. it doesn't work for all prime numbers to be odd. يعني ايه؟ اديني بس one example so that it violates اللي انت عاوز تثبته. So I'm gonna say 2 is an odd number, however at the same time 2 is even, sorry, 2 is not odd. What's going on? 2 is an even number, and at the same time it is prime. So now there exists a prime number which is not odd, which disproves الكلام ده. اوكي يا شباب؟ يبقى البروف كاونتر اكزامبل عايز اثبت ان حاجه غلط. اوكي هات كيس واحده تثبت، ساعتها تعوض في الحاجه دي وتثبت انها غلط وخلاص. كيس واحده كفايه في الكاونتر اكزامبل. دول البروف ميكانيزمز اللي احنا اخدناها في ليكتشر النهارده. وجزء الانفيرنس رول انتوا باي ذا واي كده كده اخدتوه قبل كده في الليكتشر السابقه باستخدام modus ponens, modus tollens, conjunction, simplification, and addition, disjunctive syllogism, hypothetical syllogism. ودول كانوا أمثلة أخذناها مع بعض في المحاضرة اللي قبل كده. وactually this is a way of proving things باستخدام الproof by direct proof، أو ممكن كمان أطبق proof by contradiction عليها. أوكي، شكرا جزيلا يا شباب، و سجل لكم الجزء اللي بعده.